All right. Hello, everyone. Welcome back to Comp 2150 Object Orientation. It's the last time you're going to get to hear me say that. How sad, yeah. Oh. It feels like it's cooling down. It feels like it's cooling down. It's stifling in here when I came in. I can't tell if I'm just getting acclimatized to it or if it's actually cooling down, but I won't be offended if you fall asleep because of how warm it is. I won't be offended if you fall asleep. Here's the plan for today. We are going to just talk a little bit about the final exam. I'm going to give you an opportunity to ask questions that you might have about the final exam. And then we are going to step into doing some review of the course. So first things first, it is on Friday night at 6 to 9 p.m. There's a 3-hour time slot for you to write this. This is in the Frank Kennedy Gold Gym. I don't know how many tests you've written in person. Do you know where the Frank Kennedy Center is? Thumbs up, yes, good. Okay, everybody knows where it is. It's in the Frank Kennedy Gold Gym. The strategy has generally been like line up in the main floor, and then when the doors open, you can come up to the gyms themselves. The structure for the test is similar to what the term tests look like. So you should expect the same kind of format, multiple choice questions, followed by short answer questions, followed by a programming question. You can expect this to be about twice as long as what the term tests were. So we've got a 3-hour slot, but the idea is that this is something that you should be able to write in about 2 hours or a little bit less. It's about the same size as 2 of the term tests that we've got. The programming question is going to be one single programming topic. We're going to give you a big topic. There's a description of what we're expecting you to build for this. And then we're just going to get you to rebuild the same thing 3 times using different programming languages. So Java, C++, and JavaScript. The idea here is we don't really want, well, we didn't want to write 3 different questions, but we also don't want you to have to read and understand 3 different setups. We want you to just have the time to read one setup, understand what the setup is asking you to do, and then just do it 3 times in different languages. When you are writing things in different languages, of course, you should be doing so idiomatically, so making sure that you're doing what makes sense for C++ versus Java versus JavaScript. Seating is going to be assigned for this final exam. So if you are coming to the exam hall to write the exam, if you haven't made other alternative arrangements to write the exam, you will be required to sit in a specific spot. The tests that are being printed have your names printed on the test. It's already put on the test. It has your student number already put on the test. The sign-in sheets are all filled in already with where everybody is supposed to be sitting. If you've made alternative arrangements to write the exam in an alternate location, the correct test will be provided to the alternate location. I will send you an email on Thursday. So the day before the exam, you should expect to get an email from me that says this is what your seat number and paper number is. Your seat number is the same as your paper number. In the Frank Kennedy Gym, we're starting at seat number 1, paper number 1, and I think it's like up to 209, something like that. So all of the papers will be laid out in the correct place. You will just have to find the paper that has been assigned to you. The only thing that you need on your table in the exam is your ID, some form of picture ID that has the name that you use in Learn, preferably. So whatever your preferred name is in Learn. And some writing utensils, something to write with. Some advice that we've seen from the 2 term tests. The term test grades for term test 2, I'm sorry that it's taking so long to get back to you. I'm really sorry that it's taking so long to get back to you. You will get them tomorrow. Tomorrow, that is the only thing I have to do is grade test questions. That's all I'm doing tomorrow. So you will get this by the end of the day tomorrow. But some of the observations that we've made, commit. So when there's a question that's asking you, does this compile or not? Don't say no, but if it does, it would do this. Just say no and stick with no. Be concise. When you're writing answers to a question, try to write only as much as is necessary to actually answer the question. Something that I've seen a few times is basically providing counterexamples to what the question was asking. And while in most cases that's not technically wrong, it makes it really hard to find what your answer actually is, what you're actually trying to answer. So try to write as little as is necessary to answer the question that has been asked. For the programming questions, we wanted to make sure that you had adequate space for writing your answers down. We've given 2 pages of space per language. So you've got 2 pages for Java, 2 pages for C++, 2 pages for JavaScript. That doesn't mean that you need to write 2 pages of code. Just to be clear, it's not this is the size of the answer that we're looking for. We just want to make sure, because different people have different sizes of writing. My writing is fairly small, but lots of people have big writing. And we just want to make sure that there's lots of space for you to write your answers down. As with the previous tests, for the multiple choice questions, I'll tell you right now, there's only one best answer for each question. This is not choose many sort of thing. I think that's it. I think that's all I wanted to say about the final exam, but I want to stop and give you some time to ask questions if you have questions about it. Yeah. I don't remember off the top of my head. I think there are 11 multiple choice questions. I think there are a total of 10 short answer questions, I think, and then the 1 programming question. Yeah. But don't quote me on that. Okay, we're good. Okay, all right. Let's do some review. So our course is kind of separated into 2 halves. We have 2 halves to the course. We've got like before the term break and then after the term break. So I've just written down the topics here in that sequential order. At the very beginning of the course, we were talking about some basic OO stuff, pointers, inheritance, and polymorphism. So this was a little bit of review of 1020. This was a little bit of review of 1020. We started to talk about differences. We started to talk about some kinds of terminology related to OO. So we were thinking about things like the sending and receiving of messages, dynamic dispatch, or dynamic message to method mapping. Polymorphism, we talked about the distinction between records and structures and classes and that sort of thing. We then kind of moved on to C++, where we spent a little bit of time talking about the basics, and then we spent a lot of time talking about inheritance in C++. So how do we actually just mechanically build these class structures? And then we talked a lot about polymorphism and eventually getting into things like method shadowing. So making sure that we're declaring methods as virtual if we want to be able to override it, using the override keyword to override a method in a subclass, marking things as pure virtual by using that strange syntax of this method declaration equals 0. Then we talked about overriding, shadowing, and refining methods. So in C++, we've got this idea of overriding the behavior in the superclass for virtual methods. We have this idea of shadowing methods. We also talked about this in the context of Java and eventually JavaScript in terms of instance variables and state in a class. So what kinds of shadowing happens there? Refinement is the idea of taking what's in the superclass and then explicitly calling the corresponding super method. In Java, that's super. In C++, that's using the name of the class, : and then the name of the method that we want to refer to. In the second half of the, and then OCCF, right. I thought I was never going to say that again. Orthodox canonical class form. These are those 4 properties that we have to have on a class in a C++ program to say that it is OCCF compliant. There's no tool that's going to say this is an OCCF class or this is not an OCCF class. This is more just a guideline for us to make sure that we've got these things. So those were a null constructor, the constructor with no arguments, a copy constructor, overriding the assignment operator, and destructor, the destructor. Oh my God, the destructor. So null constructor, copy constructor, assignment operator, and destructor. In the second half, one of the first things that we did was talking about all of those forms of inheritance. To kind of wind back to that, the purpose of talking about all these forms of inheritance is less to say that these are good design decisions. They are generally terrible design decisions. They are generally very bad design decisions. It's more about being able to give a name to somebody applying inheritance in a specific way. So as an example, variance. Variance was a bad way to use inheritance, but it's something that you could do. Limitation is a bad way to use inheritance, but it's something you can do. And using this terminology to describe the way that we are using inheritance is what we were trying to get across here. This is also where we talked about Liskov substitution principle. So talking about the idea that a class is exposing an interface and a contract and making sure that subclasses of that satisfy the contract that's stated in the superclass so that we can substitute an instance of the subclass for any place that the static type of the superclass is used. We moved on to talk about encapsulation and access modifiers, and here is where we've changed our understanding of the world with Java specifically, and we're not going to use protected anymore, and we're going to use private most of the time. We're going to use protected on mutators. But all instance variables should be private. It should be fully enclosed in the superclass to make sure that changes to the superclass are actually enforcing the assumptions that we have about the state of our internal self. We talked about interfaces in Java. We used this interface keyword. We talked about default methods. We eventually went down to multiple inheritance, and we'll get to that, and talked about default methods colliding with each other, named constants colliding with each other, and what happens as a result of that. Then we went into that weird and wacky world of JavaScript, and we'll all just pretend that it didn't happen, but there's all this stuff that we had to worry about with JavaScript that we don't really have to think about with other languages, like calling methods just passes any number of variables that we want to it. We have these special things that we have to test for, like how many arguments were passed to us to decide what our behavior should be using that, arguments array. When we have a constructor, we can only define one constructor. If we want to overload the constructor, we have to have something that checks how many arguments were passed to me and then decide based on that what happens. JavaScript does inheritance in kind of a weird way, where variables, instance variables, are not inherited in JavaScript. They are instead only created when the constructor is called. Methods are inherited from one class to another in JavaScript. And then we talked about multiple inheritance. We talked about multiple inheritance in C++ and Java. In Java, we talked about this in the form of multiple inheritance with interfaces. And in C++, we talked about it in terms of uppercase M, multiple inheritance with actual separate classes that we're inheriting from. And we also talked about virtual inheritance to deal with that diamond problem, that diamond of death, where we've got one common ancestor, we've got something that separates out, and then we merge back in again at the bottom. All right, that's our course. That's our course in 5 minutes. Okay, so let's do a quiz. How are people already in this? Or did I just show it at the beginning of class? Oh, okay. That's clever. Nine more days until what? My bike is here. I have been biking the last couple of days, so I'm glad that my bike has joined us. It's been warmer than expected in the morning. Like, this morning was just beautiful. There was hardly any wind. It was sunny. It was nice. Duckman. I'll give you just a couple more minutes and then I'll start this up. My wife. All right. So the structure of this is there's a bunch of questions. I also copied some questions that were answered not super well from previous quizzes. Okay, good, great, excellent. All of these things that are in this OCCF compliant thing, they are all eligible to have default implementations. So when you declare a class, you get by default a null constructor, you get a copy constructor, you get an assignment operator, and you get a destructor. They are all there. They're all there, but they don't do anything. They just give you an instance of your object. They copy nothing. They don't actually do anything when you try to call that. The assignment operator merely makes a new object from the one that's there, but it doesn't copy anything because it doesn't know about anything. The destructor doesn't destruct pointers that the class owns. These things are part of the class, but if you don't define them, but they don't do anything meaningful. When you have things like object memory that you own and refer to, that's where you would call delete in your destructor. When you have primitive values that you do want to copy between classes, that's where you would set this up in a copy constructor and an assignment operator. The copy constructor is that one of the places where we're using object references. That's that ampersand thing. Okay, good. The dog even has little hearts above it. Oh, okay, okay. You can do duck typing in Java. Duck typing, remember, is this idea that we can basically ask an object, do you have this method so that I can try to invoke it? You can do this in Java. We don't because it's very painful. We don't because it uses reflection. This was a complete aside in class, just an aside. We can do this because we can ask an object what class it is, we can ask what methods are on that class, and then we can get methods by a specific name. So we can find out if this class has a method. It's painful. I love that this duck looks like it's smiling. I'm sure that somebody has made this, photoshopped it, but they've done a good job of even doing this in the reflection if it has been photoshopped. Oh, fell right off the top. Good. Yes, thank you, good. No, you should not do duck typing in Java. Duck typing is something that makes sense in a language that has dynamic typing, where you don't necessarily know when a line of code executes if something has a method attached to it. You can do this in Java, but it's really painful to do it in Java, and you should really be using the static types and classes that you've got to decide whether or not something has a method. When we did this duck typing example in Java, we had a catch block that caught, I think, 6 different kinds of exceptions to be able to accomplish this. It's not great. Okay, all right. Dynamic class binding, remember, is this idea that we can assign an instance of a subclass to a statically typed variable, and this happens at runtime. So as we're executing code at runtime, we don't necessarily know, based on the static type, if something has an instance of that or one of its subclasses. That is true of all of the languages that we've got. So C++, we have the ability to do this with pointers. Java, we have the ability to do this with classes. JavaScript, well, we just always have this ability to do this because it's a dynamically typed language. Specifying behavior with interfaces, this is actually unique to Java. This is unique to Java. We don't have interfaces as far as we've seen in JavaScript. The only way to specify behavior in JavaScript is to write classes that throw exceptions when you try to call methods on them, and throw exceptions in the constructor when you try to call the constructor directly. That's the best we can do in JavaScript. In C++, the best we can do is create pure virtual methods, but that doesn't restrict us from adding implementations of our own to that class. Encapsulation with private as an access modifier. Well, we didn't actually use the word private to describe this, but we have that octothorpe, that the hash mark, oh my God. Hashtag. We have the hashtag symbol. That is something to use to mark something as private in JavaScript. Dynamic superclass modification. As far as we know, we can't do this in C++, and I'm pretty sure you can't do this in C++. You can kind of do this in Java. You can kind of make dynamic instances of something without actually declaring a class. But it's way outside the scope of this course. Dynamic superclass modification, this is where we were doing things like changing the prototype of a class and where we were mixing in behavior to a class. Dynamic superclass modification is unique to JavaScript in this course. All right. Okay. So dynamic cast, remember in C++, this is a C++ specific question, we don't have instance of. There's no way for us to ask, is this an instance of this other class? The only option that we have is to try doing the cast and seeing what the result is. So asking, is this thing that we get back non-null? However, in C++, null is not a keyword that we can use. It's null pointer. I don't know why it's changed this way in C++. I don't really understand a lot of things in C++. I don't understand a lot of choices in the design of the language in C++. But null pointer is what we get back from dynamic cast if the cast fails. And the cast is going to fail when it's not of that type. It cannot be assigned to that type. Taj has got a good hold on that first spot here. Okay, good. So package private, this is that modifier on instance variables and methods where we don't put an access modifier. Previously to learning about package private, we were doing public, private, protected. Those are the three options that we had. Package private, just don't put an access modifier on it, just declare it. Package private specifically says that everything that's inside the same package as me has access to this thing. Everything that's in the same package as me has access to this thing. Things that are outside of my package don't have access to it. So if you have two packages and one of them is declaring instance variables as package private, nothing in the other package can access it, even if it's a subclass. Protected, on the other hand, gives us the ability to do that. Package private prohibits us from doing that. All right. Okay. This is one of those, there is one best answer sort of questions. There's one best answer here. This is a good answer. A specification of behavior in constants but not state. That is true. That is a true statement, yes, but that's not the best answer to this question given the options that we've got here. In Java, an interface it's not an abstract class. They're two separate things, so that one's not necessarily true. This one here, a specification of behavior with optional implementations. And optional implementations here are the form of default implementations in an interface. I still use the word data here, and this is something that I used in class specifically to describe the idea of what we have here. There are named constants that we can declare in an interface in Java, but we can't declare state in an interface. We're not allowed to have state in an interface. This one is pick multiple options. You have to pick multiple options for this to be correct. Okay, so the situation that we've got here is that we have interfaces, and we have one single class that implements both of them. So they're separate interfaces, but we've got one class that's implementing both of them. If two of those interfaces share a method signature, and it's got default behavior, then we must provide our own implementation. If those interfaces don't specify default behavior, we still have to provide our own implementation. If we don't provide our own implementation and one or more of them has a default implementation, it will not compile for us. We have to do that. If we have multiple data, so we've got multiple variables, multiple constants that have the same name across these interfaces, then we can't refer to it by the class that implements the interfaces. We must refer to it by the specific interface that we want to get it from. If our class that implements multiple interfaces has interfaces where there are no data collisions, we kind of inherit that data. We get those named constants, and we can use our class name to refer to it. This option here, the class that's calling the method, when I'm calling the method on an object, I don't care which interface it comes from. I don't really care which one it comes from. When I'm implementing a class that implements multiple interfaces, what we were able to do is refer to a specific default implementation. This is that place where we were saying that we've got a class that implements these interfaces, and I'm going to define the method inside my own class, and I'm going to say this interface name .super.method. That's how I can do that. But when the calling class is calling methods on an object, an instance of an object, we don't really care which one it comes from. We just want to call the one method that is going to be answering the question that we've got, the message that we've got. Is that okay with everybody? Okay? Okay. I love this picture. All right, okay. This one's kind of all across the board. This was one of the most recent things that we did, so fair enough. Virtual inheritance is where we have this common ancestor, and we have multiple inheritance at some point in our hierarchy of classes. How we refer to duplicate instance variables in multiple inheritance. This is really just class name that declares the variable : and then the name of the property that we want to refer to. It's true, but it's kind of outside of virtual inheritance. This really doesn't have anything to do with virtual inheritance itself. Kind of like include, but for instance variables and methods. What I would say for this one is that that's more like what inheritance is itself. So include is kind of like what inheritance itself is, where we just get methods and data from our superclass, or methods and state from our superclass. Kind of like pragma once, but for methods. I really like to think of virtual inheritance as pragma once. I am specifying which thing I want to bring in. But for methods in this case, doesn't really make sense. I do want to have the methods that I have from this common ancestor. And it doesn't matter if they're inherited twice, because it's behavior. If I've got this common superclass, and then I've got this thing that breaks apart and merges back together again, at the bottom, the behavior that I get from that one at the top, it's the same behavior. It's identical behavior. So it doesn't really matter which one of those I get, which path I follow through the tree to get that behavior. Kind of like pragma once, but for instance variables. So we've got that superclass at the top, that common ancestor. It declares state. As we go through this branch and merge again with multiple inheritance, we're getting duplicated state from both of the paths that we have through our parents back up to that common ancestor. Virtual inheritance is letting us say, when you inherit from me, only take one path through this. And what that kind of means is merge that state into one block of data. Merge that state into one block of data. It didn't change. It didn't change at all this time. Okay, great, good, excellent. A pointer it's a variable containing an address. An object reference is an address. This led to that weird ability for us to do things like take as a parameter an object reference and then assign to that object reference. So actually put on the left side of the equal sign the variable name and actually change the contents of memory in the caller. This one, we can change an object's instance variables through a pointer. We can do both. With object references, we use that dot notation instead of the arrow, but we can accomplish the same thing. We should always use pointers and never object references. We don't have a choice in a lot of cases. We want to have a copy constructor. We have to use an object reference to be able to do that. Good. I heard somebody say, oh shit, JavaScript. Okay, so can we shadow methods? Just so we're on the same page here, shadow is, we've got the same signature in parent and subclass. And we can refer to specific methods on an instance of one of those classes using the static type that has been assigned to that variable. In JavaScript, we don't have static types. We don't have a static type that's attached to a variable. So method shadowing doesn't really happen. Method shadowing doesn't really happen. We can't call private methods. So this one is false. From outside the class, we can't call a private method. So we can't get shadowing effects here. Yes, but only public methods. This one actually gets overridden by this answer. So no, later method definitions always override previous method definitions. That is true. Within the same class, if we define the same method multiple times, it's just the last one that's there that happens to be the one that we're able to call. The other ones effectively don't exist because remember, objects in JavaScript are just maps. The map that we have are tables. The table that we have, the key is the name of the method. The value is the function that we're invoking. So every time we redefine a new method, we're replacing that entry in the table of what that object is. Polymorphism is always on in JavaScript is the best answer here because polymorphism is always on in JavaScript. We don't have static types that we can refer to. So when we're calling methods on an object, we're always calling what that instance actually is at the time that we're calling the method. Taj is holding on to that top spot there. Great, good, excellent. It is cooled down in here, but like barely. Yeah, it's hardly noticeable. Variance is a form of inheritance. It's one of the described forms of inheritance where we have two unrelated things that have common behavior, and we just arbitrarily choose one of them as a parent class and one of them as a subclass to share behavior across those two classes. Covariance is this idea of we have the same method signature in a superclass and a subclass, but we're refining the type in the subclass of the argument or the return type that we're accepting as input to that method. All right. Okay, so we're kind of split between these two options here. This is, again, one of those best answer sort of questions in the context of our course. Construction definitely adds methods to our class that we might not be expecting. That's true. And that's almost certainly related to this. There will almost certainly be bugs in the code that we've written because we have extra surface area that we weren't expecting to be there when we extended a class. In the context of our course, when we were talking about construction and the forms of inheritance, the major flaw here is that we are almost certainly going to violate Liskov's substitution principle. So we're going to declare this subtype of a class, and then if we tried to do replacement or substitution, it would behave differently than what the superclass and the contract is stated for that implementation. So we will almost certainly violate Liskov's substitution principle is the best answer here. Good. Okay. So this is effects of shadowing in Java. In this code fragment, in our main method, we're never referring to the subclass. We don't create an instance of the subclass. The static type that we have on S is of the superclass. Everything is entirely contained within the superclass. So when we try to print out the value that is in an instance of that class, it's just everything that's entirely contained within the superclass. We are still referring to the static type of the variable. We are still referring to the static type of the variable to decide which one we're going to print out. But because it's actually an instance of that class, well, we get what we expected to get out of it. Okay. For the record, this response rate improved from last time, so that's good. It's improved from last time. In our main, we are declaring an instance of small shadow. Yes, we are declaring an instance of small shadow, but the static type that we have attached to this variable is of the superclass. When we are referring to the variable name here, value, we're referring to the static type that's on the variable that we're looking at. When we call the constructor of small shadow, In Java, this variable value is contained entirely within the context of the subclass. We call the superconstructor, and it refers to this dot value, but it's referring entirely to the one that's contained within the superclass itself. So there's two variables in this hierarchy that are both named value, but within the scope of those two classes, they are referring to different variables. When we print out this message here, what we're referring to again is the static variable, the static type of this variable, which is that of the superclass. Good, 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 perfect. Yes, excellent. I don't even need to explain this now. Yeah, we're referring to the static type on the variable. It is of the subclass. Yes, it calls the superconstructor. Yes, the superconstructor says this dot value, but because we're explicitly referring to the static type of the subclass, we get the value from the subclass. Great. Let's switch to JavaScript now. Oh no. Great, good, great. I still want to step through this. I still really want to step through this. We've got these two classes. One of them extends the other one. The setup is identical to what we had with Java. We're creating an instance of the superclass here. The superclass never refers to the subclass. It never ever refers to the subclass. So when we print out the dot value on this object, what we get out is what the superclass has defined when the constructor was executed. When the constructor is executed on the shadow class, the superclass, this dot value does not exist in the object's map until that line of code is executed. It's not part of the class definition. It comes into existence after the constructor has been invoked. So after that line of code is executed, now that object has a property that's called value, and it has a value that's of shadow. Okay, good. There was something confounding in this one. I again want to step through this just to make sure that we're all on the same page. The superclass called shadow, when it's read, has two methods that are defined in it. So we've got this superclass. When we extend that one, we inherit the methods that are in that class. This dot value does not exist in the class until that line of code is executed. We don't have instance variables until we've added it to the object itself. In small shadow, in the constructor, and this is a little quick aside here, remember that with JavaScript, if we extend a class and we define our own constructor, we must call the superconstructor. You have to do it. You do not have a choice. Your code will not run or compile if you don't call the superconstructor in the subclass. In the subclass, we've got the call to the superconstructor. We bring in value. There's just one single value here. The confounding part of this one is that we're printing using this print method. When we're printing using this print method, the print method is inherited. It is indeed inherited in the subclass. But because calling the constructor on the subclass has modified the value of this dot value, it's changed it to small shadow. Even though the method is defined in the superclass, we still get the value that has been overwritten by the subclass constructor. I don't know who Taj is, but I'm really impressed. I'm really impressed. It has just been at the top the whole time. Congratulations. And I'm sorry if I ruined it. Okay, great. Good. There's some things I want to point at and wave here. Private variables in JavaScript. If we do not pre-declare the private variable, so if we don't have this statement of this class has a variable that's entirely contained within this scope, if we have nothing here and we try to print it, we would get an exception raised. It doesn't exist unless it has been marked as part of the class. Despite being marked as part of the class, similar to other public instance variables, we still do not inherit those instance variables. So they're private, but we don't inherit them. Private instance variables in JavaScript are entirely contained within the scope of the enclosing class. So we create an instance of shadow here. It's going to assign to this private variable shadow. We print it. It prints out this dot value in the enclosing scope. The private variable is entirely contained within that class. We never refer to the subclass here. All right, okay. This code would compile. This one would compile. C++ is unique in the languages that we've looked at in that polymorphism can be turned on and off. Because in the superclass, this method called area has not been marked as virtual, that means that we're going to refer to the static type to decide which method to actually invoke. When we declare an instance of this class here on line 2, yes, we are creating an instance of the subclass square, but the type that we've given to the pointer is a pointer to the superclass. So when we try to call this method on the instance variable, which has a static type of the superclass, we are referring to the method in the superclass. We could turn polymorphism on, but it's not turned on in this case. Dank Frank is moving up. Nice. Good. This is a covariant polymorphic method. Copy in the superclass is marked as polymorphic. It's marked as virtual. Subclasses that override this method will have that method called on them when they are an instance, regardless of the static type. The return type, on copy in the superclass is of the superclass. The return type on copy in the subclass is of the subclass. These are polymorphic. They are covariant. They are covariant. The type is narrowed in the subclass. This is the only place in C++ where it makes sense for us to allow this to happen, or this is the only place where it is allowed to happen, where these are the same method despite the differences in their signature. So when we override this in the subclass, we're overriding the method in the superclass despite the change in the return type of the method. This is the last one. All right, okay. These are covariant methods. In the superclass, we have the superclass as a parameter type. In the subclass, we have the subclass as a parameter type. In C++, covariance is only allowed on return types. As far as the language is concerned, these are two different methods. They are completely different methods. The compile time error here is this method is marked as virtual. The shape class can still have its own implementation of that, but we're allowing overriding to happen in the subclass. The subclass says override. But the problem with this override here is that this method, calc area with parameter type square, does not exist in the superclass. These are two different methods. They are different methods because their parameter types are different. Covariance, even if it is covariant, is not allowed on parameter types and methods. So this code would not compile. Yeah. Okay, drum roll everybody, please. This is the big one. Taj. Congratulations, Taj. That's very impressive to be up at the top the whole time. All right. So with that, I am going to end the class. I don't have new material for you. At this point, you should now hopefully be able to write a final exam. You should hopefully be able to write a final exam. I wish you all the best of luck with the exam. I wish you all the best of luck in your future. Thank you all for coming out with me. I'm going to stick around here until 3:45. If there's questions about the assignment, come and ask them. If not, I'm going to go home. I will see you all on Friday night. Bye, everyone.